Section 6.7 is on graphing linear inequalities and two variables. So now we have two variables, not just one, so when we graph, it's not just going to be a number line, we're going to graph on the coordinate plane. So here are steps, just in case you forget exactly how to do this, you can look back on these steps. So these are steps on how to graph inequalities in two variables. What we're going to do first is we're going to graph the boundary line. And we're going to use a dashed line if we have less than or greater than. And if it's an or equal to, a less than or equal to, or greater than or equal to, it's going to be a solid line. Just like you had open dots and closed dots. We have dashed lines and solid lines. So now to find out where we're going to shade, we're going to pick a test point to see whether it's a solution or not. And you're going to shade the half plane that contains the point that's a solution. So if you get a point that's not a solution, you're going to shade the other side. So let's go through some examples. First one, y is greater than 4x minus 3. So your first step up above was to graph the boundary line. This is solved for y, so this is mx plus b, this is my slope, and my y-intercept. So if I go to graph this boundary line, I'm going to go to my y-intercept, which is negative 3. So I go down 3, put a dot, and then use my slope of 4 over 1. So I go up 4, 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. And now I'm either going to have a dashed or solid line. Since this is not or equal to, it is going to be a dashed line. Now your last step is to find out where you're going to shade. So you need to pick a point on the graph, plug it in, and find out if it's a solution. I would suggest picking 0, 0 if you can, because it's simple, it's 0, 0. If your line goes through this point, you can't pick it, you have to choose something else. Because the point you pick can't be on the line, because then we can't figure out what side we have to shade on. So if I pick the point 0, 0, right here, I'm going to put 0 in for x and y. So I have 0 is greater than 4 times put 0 in for x minus 3. Now when I do this math, 4 times 0 is 0, so I have negative 3. So is 0 greater than negative 3? Yes, that is true. So I'm going to shade towards this point because this point is true. This point is a solution. So I'm going to shade towards 0, 0. So I'm going to shade on this side. And that's my graph. So let's do another one. So before I graph on this one, I'm going to get y all by itself so I can see my y-intercept and my slope. So I'm going to subtract x to the other side. And you don't have to write 0 minus x, you can just write negative x. And then divide both sides by 2. So this is my equation. And the slope is always with the x term, so my y-intercept is 0. So I start at 0 and use my slope of negative 1 over 2. So I go down 1 over 2, down 1 over 2, and it's going to be a solid line because it's less than or equal to. So I go ahead and draw a solid line. And now I need to figure out on which side am I going to shade. So I choose a point, which this time we cannot choose 0, 0 because our line goes through that. So choose some other point, like this point, which would be 1, 1. So if I plug in 1 for y and 1 for x, and it doesn't matter which one you plug it into, if it's this one or this equation, but I always like to plug it into the original one. So I'm going to plug in 1, 1 up here for x and y. So I have 1 plus 2 times 1 is less than or equal to 0. So 2 plus 1 would be 3. So is 3 less than or equal to 0? Well, no, that's false. 3 is not less than 0. So since 1, 1 is over here and it's not true, you're going to shade on the other side, because everything on this side are solutions. I have two other quick examples for you that deal with horizontal and vertical lines. So if we had the line y is greater than -3, the boundary line at y equals -3 is just a line at -3. And it's dashed because there's no or equal to. Remember, if it's y equals, it goes through the y-axis. Now to shade this, if I pick some point like 0, 0, and I always said plug it in for x and y, well, you see there is no x here. That's okay, just plug in 0 for y. So I get 0 is greater than -3. Is that true? Yes. So I shade everything above this line. And these ones are simple to shade because if you want anything greater than -3, you're going to shade up. So these ones are pretty common sense when it comes to shading. And this one is just the same, except it is a vertical line. So if I have x is greater than -1, I have a line at x is -1, this is the x-axis, this is -1. It's a dashed line because it's just greater than, not greater than or equal to. And if I'm shading anything greater than -1, well, this is more negative, so greater than would be on this side. So I shade greater than. And if I check the point, like if I plugged in 0, 0, is 0 greater than -1? Yes, it is. So you should shade on this side. So I want you to go ahead and try graphing this inequality. Y is greater than -2x plus 3. Remember, it's going to be a dashed line because there's no or equal to. And then you have your y-intercept and your slope. And then find out which side you shade on.